Finding yourself bored and numb? Well, no worries, because now you can get the all-new Ink Pods. So now you can listen to math on the go or on the road. So why stall? Get the all-new Ink Pods today.
Directions for each graph. Answer the following questions based on the scenario. For an algebra class, all students take a Unit 5 test. Their scores and the amount of hours they study are contained in the graph below. Each letter represents a student. A. Which data set is labeled on the x-axis? X-axis is here, so that would be time spent studying. B. Which data set is labeled on the y-axis? Well, this is the y-axis, so that would be score on the test, which would be that choice. What type of correlation is illustrated? Remember, you're going from left to right, so it looks like that would be like the best fit of line, so it would be this one right there. D. Which student or students scored the highest? So there, it could be more than one. So the highest score would be here at 100, which would be both H and J. E. Which student scored the lowest? So there it is. That would be student B. And then for the students that studied 0, what were their individual scores who studied 0? So this is 0, and anything on there, so I have 80, 60, and 50. 80, 60, and 50. So these three choices. Okay, let's go on to question number 2. Directions. For the graph, identify the key parts that create an equation for the given trend line in the slope-intercept form. Remember, the trend line, that's just another way of saying best line of best fit. Line of best fit, or we've been using the abbreviation in class, the least squares regression line. Okay? So the graph represents the total amount of hours worked and money earned for 11 workers. Each letter represents a worker. The orange line represents the trend line that best fits the data. What is the slope of hours? Okay, so to figure out slope, you can do a couple things here. You could make a table of values, right? And then each person, A, B, C, D, you could do that. That's one way of doing the problem. On the line itself, you could just pick 2 points that are close to it. So, for example, I might say something like here and here. Okay, so I have a rise, that's slope, right? Rise of 10, and then a run of 1. So 10 over 1 is my slope. So that would be my slope, 10. What is the y-intercept? Well, this is the y-axis, and where is it cross? Right there at 0. Okay. What is the slope-intercept equation? So again, that is y equals mx plus b, and we just said our slope is 10, so that's going to be 10, and then our y-intercept is the b value, so you have 0 there. So you can have y equals 10x plus 0, or y equals 10x would be acceptable, either of those two. Okay. D. Based on the average rate of pay for all workers, after 3 hours, how much would you make? Would you expect to make? So money earned on the graph is the y, and hours worked, that would be your x value. So x equals 3 here. So I'm just going to use the equation we just wrote, y equals 10x, and just simply put in x equals 3 here, and I get y equals 10 times 3, which gives me y equals 30 is my answer. How much money would they make? $30. Alright, next question. Person H, that is this one right here, and person I both made the same amount but for different hours. Which statement is true? So here are all of my true ones here. So H made $35 and did that in 3 hours. And the other person, I, made $35 but did that in 4 hours. Okay. Person H makes more money per an hour. False, because they both made same amount. Person I makes more money per an hour. So again, they're telling you, let me backtrack on that one. So yeah, this one would be money per an hour. Should did it this way. And so, that person's probably going to make what? 1 goes into 3, 3 goes into 1, 2, 0, $11.60 an hour. And then this person is making 32. I'm just doing division. I don't have a calculator in front of me. So 832, 30, 870. So which statement is true? So that's singular. H makes more money per an hour. Yes. I makes more money per an hour. No. Person H works harder. I think they both work hard. Both workers make the same amount per an hour. And my answer would be for E here. This one, right? Whoops. That's supposed to be highlighted. F. Which of the following people worked the most hours overall? Okay, so then I'm just going to write down. Person H worked 3 hours, so I'm looking at the x-axis. I worked 4 hours. Person K worked 5 hours. And person A worked 1 hour. So which person worked the most overall hours? That would be person K. Is the correct answer. Okay, let's try number 3. Determine the correlation for each situation. Choose positive, negative, or no correlation for each. Okay, so I'm going to the weight of the bag, weight of baggage. So like, you go onto an airplane thinking 0 and 100 pounds. Someone carries, and the speed at which they can move, miles per an hour. So I just put 0 and 100. Okay, so I'm thinking to myself in this problem, let's say I'm at the airport and I have a very heavy bag. Can I run, this way. I have a heavy bag and I can probably move very slowly. But if I have no bags, I can probably go 100 miles per hour. Something like that, right? So I think we have here a negative. Does that make sense? My trend line is negative going down like that. Number 4. The graph below shows the ages of employees in a company and the average salaries for that age. Okay. Based on the graph, indicate whether each of the 3 statements below is true or false. Okay, so, well, first of all, it says 3, but there's only 2, so that's fine. There is a fairly strong correlation between age and salary. So if I draw a line, is that pretty strong? I would say the answer here is true. Okay, the data shows that that salaries are higher. So as this is going up, are for only older employees. Yeah, so someone who is age 60, they're getting a salary that's like $80,000, and the young one, if you're only 25, low on age, and you have low on wage, right? So that is also true. Number 5, directions. Choose the best response. Okay. The baseball coach graphs some data and finds the line of best fit. The equation for the line of best fit is y equals 0.32x minus 20.51. X represents the number of times at bats, and Y is the number of hits. So how many hits is the question, right? And that means Y equals. So hits is Y. So what is Y? If we expect from a player who is at bat 75 times. So bats, or goes up to hit the ball, is X. So X equals 175. So here I'm putting here 175. And I get Y equals 0.32 times 175 minus 20.51. And if you put that in your calculator, you'll get close to something like 35 hits. So A is my correct answer. Oh no. Let's go find number 6. All right, let's go over question number 6. Consider the figure. Here it is, and we have to complete the sentences. So the data has a what type of correlation? Blank correlation. It is going that direction, so this would be a positive correlation. B, this indicates that the R value must be positive or negative. Well, that also has to be positive. The data are close to forming a what? Curve or straight line? I would say a straight line. And R would have to be equal to would be the most accurate. So I'm looking for a positive number and strong, so that would be this one right there. Okay? Question number 7. The linear regression equation for a data set is y equals 1.6x minus 4.1. The actual value at x equals 3 is 0.9. What is the residual value of x equals 3? So, just give you a super fast idea. Negative 4.1 and has positive slope. So this is my regression line. Okay? But they're saying at x equals 3, it's, I don't know, maybe this is 3 and 0.9 is 0.9. So what is the residual? Is it going to be above or below? That's kind of like the idea they're talking about here, okay? So a couple of steps that we talked about previously were for you first to calculate the expected. Calculate the expected. So that would be using this equation, and I'm going to put a hat there because it's the predictor. And from the expected, right? From this prediction, we are actually getting the expected, okay? Okay, so then we're going to put in our x value of 3 here. And then I have everything that equals the same. Let's take out my handy-dandy calculator. I get 4.8 minus 4.1. So I have 0.7. Okay, then from here I'm going to calculate the residual. What is our residual? Well, you have a formula, right? The formula is the residual is equal to the AP. Actual minus the predicted. Okay, so our actual is 0.9. And the predicted is 0.7. Oops, did it again. And therefore my residual is equal to 0.2 And that would be choice B as your answer. And then I'm going to go to Stat. I'm going to press Edit. And go up to the top of your list, where you want to highlight L1. So it's I have an iPad, so you can just highlight L1 or just press the up key until you get there. Press Clear and then Enter. Clear. Okay, and then I'm going to do the same thing for list 2. And I'm just going to go ahead and put in my numbers. Okay, remember from lesson 2.4, we talked about how you need to first do the diagnostic. Make sure that is on. So the calculator commands for that are second 0. It's going to bring up the catalog, and you want to look for diagnostic, which is a D. You want diagnostic on. Whoops. We're supposed to do it on the home screen. Let's try that again. Second 0 to get the catalog, diagnostic on. Press Enter. Okay, now it's on. Okay, now I'm going to press Stat, Calc, and then you're going to look for a linear. You do have like regression there, 3, but I want to focus on 5 and 8. If you guys look at 5 and 8, they're pretty much the same. And I think in class I used number 9. 5 and 9 are exactly the same. You'll just notice that A and B are switched. So just pay attention that slope is in front of X. So I'm just going to press this one. And then it tells us to put in your list name. So now I'm going to press second 1, give me list 1, then comma, L2, second 2. You can close the parentheses if you want, you don't have to. Okay, so here, this gives me all of the printout we need. So I'm going to take a picture of this. Alright, so now we can go back to our notes and we can calculate R value by technology. We'll do it by hand. Is 0.967, and I'm going to round 7. Okay, this is my R value. Okay, remember for regression R, there's a formula. So let's do this by hand now. R equals 1 over n minus 1 times the summation of all of the x values subtracted by the make a mistake, just move it over, and then we can just go back and write. I forgot to multiply that by the standard deviation of x times standard deviation of y. These values Alright, so let's go back in the list and let's go get some information that we need. I want the standard deviation of, so a couple of things, let's write this out. We need Sx and then x bar, and then we also need standard deviation of y and the mean of the y, or the second list. Okay, so let's go and do that. Now we already have the information here, so you can just press Stat, Calc, one of our stats, and here I just want L1. So that would be second 1, or you can also press second stat. Let me show you that one. And it has the names. Okay? Okay, this is what I wanted. So there you see X bar and Sx, which is the sample standard deviation, which is the one we want. And again, why do you want a sample? Is because we don't have the whole population. Those lists are just a couple of children's heights. Okay? And I'm going to do the same thing. Stat, calc, one var stats, and then here I just want L2, so I'll do it a different way. Second 2. Okay, and then there's our information. All right, let's go back to our notes. Okay, so for SX, I got 1.58 in X bar to be 20. And for the second list, we got the average to be 77.64 and standard deviation to be 1.08. Remember, the n value is how many people you have in this list, so there are 1, 2, 3, 4, 5 people, so n equals 5. Okay, so then we just create I like to create a chart. Show you my chart. Okay, so I want the age, so I'm just going to write, this is my first list. So this is like my X. I'm just going to write those numbers: 18, 19, 20, 21, and 22. And then the second list we had in yellow, which is the height down here: 76.1, 77, 78.1, 78.2, and 78.8. Okay, in this list, I'm going to subtract each of the x values from the mean. Okay, so that's going to be, nope, this one. 18 minus 20, 19 minus 20, 20 minus 20, 21 minus 20, and 22 minus 20. Alright, so we're going to get some numbers here: -2, -1, 0, 1, and 2. Guess we didn't need this one. And now I'm going to let's use darker color. Y values minus y hat. So that would be 76.1 minus 77.64. Seventy-six point one, 76.1, 76.1, 76.1. And let me show you guys again how to use this list aspect. Super helpful. Okay, so we know it's, watch what I do. Alright, I'm going to go back to my list. So I'm going to go to Stat, Edit. I'm going to use an empty list, so I'm going to go up to List 3 and press Clear. Okay, and with L3 highlighted, I'm going to press L2, so second 2, and you can see the blinking there is where my formula is, and I'm going to subtract it by the mean, so I'm going to have to just write that minus 77.64. And what I've done there is my list now is kind of doing all the subtraction for me, and I can just copy down those numbers. So this will be negative 1.54, negative 0.64, 0.46, I made a mistake on those. So I copied the wrong number there. Did you guys see that? I was like, oh, subtract those numbers, they don't look right. Okay, those numbers look better. Because when you subtract a bigger number by a smaller number, you get a positive. And then this is 1.16. Okay. Do I have any space over here? Oh, awesome. Okay, what we need to do now is we're going to take our two lists. X minus, and the I just means the I is the number in the list, so it's the first number in the list. You're going to take that list and multiply it by this list. So all those in underline we're actually going to multiply. Okay, so I should have done that trick to the next list. So let's just do the next list. You guys want to play Cooking Fever? Okay, so I should have done in this list, press clear. I should have done xi, so that's the first list, minus the average, which was 20. And those were the numbers we got. And why do I want those two numbers? Because I can go to list 5, press clear, right? And now I can multiply list 3 times list 4. So second 3 times second 4, which gives me L4. Okay, and then I have these numbers. Take a picture of this one. Okay, now we can go back here. And now it's actually multiplied these numbers for us. So negative 2 times negative 1.54 will give me 3.08. Positive 0.64, 0.56, and 2.32. And then this, if we add that number up, so this is, let's tell you what I've done so far. I don't know if this is helpful. This is in list 1. This was in list 2. I made a mistake. Let's see, this is L5. We put this one in L3, and this was list 4. I kind of mixed them up, but okay. What I'm going to do now is I'm going to do 1 bar stats for list 5, and why I'm doing that. So I go to the home screen, second mode, clear all that out, stat, calc, 1 var stats, list 5, so second 5. And the reason why I did that is I wanted the summation. I wanted it to add up everything, which gives me 6.6. Do you see that? The backwards EX, the second one on the list on the left column, so 6.6. So the summation of all of that is 6.6. Okay, let's go back to our formula now. Let's do our trick. Oh, let's try again. It's close. It worked. Alright, let's just substitute all this in now. So R equals 1 over 5 minus 1 times 1 over standard deviation of x is 1.58. Looking up here, times SY 1.08 times our summation, which was 6.6, share this. I can put it on my calculator to show you. So I'm going to multiply all of the numerator in green, and then we'll multiply everything in yellow. So, or you can just do 1 divided by 4. So that's the n minus 1, 5 minus 1 is 4. Okay, this one I'm going to use double parentheses. I'm going to do, that's my numerator, and this is my denominator, 1.58. That's cool, it highlights it red. I wanted 1.08. I'm going to do one more set of parentheses. Never hurts. And then you put 1 right here. Second insert right there. Okay. I know, crazy amount of parentheses. I just don't want to make a mistake here, that's all. And there it is, 0.967. That's the number that we wanted. Okay. So that matched our calculator by hand.
I'm Mr. Ing's mom. Do your homework.